In this video, I want to figure out how to perform the EM algorithm for our mixture of Poisson's model. And we'll do it kind of the way it was introduced for the mixture of Gaussian's model, so kind of a little bit heuristically. So to remind you, what we know is we have this data set, so K1 through Kn, and we know that it comes from a mixture of two Poissons. So we have the parameters lambda1 and lambda2, and we have the mixing proportions pi1 and pi2. So each of those k's comes from Poisson lambda1 with probability pi1, comes from Poisson lambda2 with probability pi2, where pi2 is of course just 1 minus pi1. So okay, how do we approach this? By doing kind of the heuristic self-assignments thing. So what we want to know is, okay, so we'll define again our variable zi, and it's going to be 1 if ki comes from Poisson lambda 1, and it's going to be 2 otherwise. And what we want to know essentially is, okay, so is zi equal to 1 or is zi equal to 2? So we want to know, at least probabilistically, where did each of the k's come from. So if we want to write it down kind of in the language of probability, we'll say, okay, so we're interested in knowing what's the probability that zi is equal to 1 given ki, and assuming that we know the lambda and the pi. Okay? So how do we compute it? So in a previous video, we already saw that we can compute ki given zi. So we should just kind of massage this into something that involves ki given zi, because that we know how to do, right? So what is that going to be equal to? So this is going to be equal to the probability that ki is occurring given that zi is equal to 1, and of course lambda and pi, times the probability that times the probability that zi is equal to 1, given lambda and pi, divided by the probability that ki is happening, given again lambda and pi. So we know how to compute this, by the way, but we don't really care, because what we really care about is the denominator. So we can just say that this is going to be proportional to the probability that ki is happening given zi equals 1, and lambda and pi times the probability that zi is happening and is equal to 1 given lambda and pi. So why is it enough to say that it's proportional? Well, because the only two options are zi is equal to 1 and zi is equal to 2, and we know that both of those are going to add up to 1. So, okay, what can we do now? We can say, okay, so the probability that zi is equal to 2 given ki and lambda and pi, well, that's going to be, again, just proportional to the probability of ki given zi equals to 2 and lambda and pi, times the probability that zi is equal to 2 given lambda and pi. So we actually know how to compute both of those expressions already, right? So what we can do is we can say, okay, so p zi equals 1 given ki lambda pi, that's going to be proportional to the Poisson probability mass function, right? So that's going to be p lambda 1 of ki times pi 1. So this is just ki given zi equals 1, and this is p of zi equal 1 given pi. We don't really care about the lambda here. We don't care about the pi here. It's like this. So the probability of zi is equal to 2 given ki and lambda and pi. That's going to be proportional to p lambda 2 ki pi 2. And now we're done. So now in order to get this exact thing, we just need to say, okay, so this is proportional to this is proportional to this, and they both add up to 1, which means that the probability of zi equals 1 divided by ki lambda pi is going to be equal to p lambda 1 ki pi 1 divided by the sum of these two. So divided by p lambda 1 ki pi 1 plus p lambda 2 ki pi 2. Okay, and by the way, well, obviously this is this, but we knew this already because this is just the sum over zi equals 1 and 2 of this guy. This is exactly what we did when we were computing the likelihood in the first part of this question. Okay? So, okay, all right, so this is p of zi equals 1, and p of zi equals 2 is obviously going to be computed exactly the same. So this is the E step. So we're going to be using this quantity later on. So how do we interpret this again? So this is for every case. So we take this k, and we assume that we know the lambda and the pi. Well, this is the probability that a given k came from either the first so this is the first Poisson distribution, and the other quantity, p of zi equals 2, is going to be the probability that it came from the second Poisson distribution. Okay? And you can see that it makes sense, right? Because this guy is going to be large if ki is close to lambda 1. On the other hand, this guy is going to be large where ki is close to lambda 2. So if both of those are small, then probability of zi equals to 2 is going to be large. If both of those are large compared to this guy, then this quantity is going to be large. Okay, so the last thing before we end this video is to say, okay, so let's call this guy wi1. This is going to be p of zi equals 1 given ki and lambda and pi. And let's call the other thing wi2. And that's going to be the probability that zi is equal to 2 given ki, lambda, and pi. That's the step.